Hi there, hope you have a fantastic day today. This lesson I will teach you how to prove some of the dot products that involving component form and the angle between two vectors. So let's go straight into it. So let's just have a look at this syllabus dot point. So by the end of this video, you should be able to derive this, and this rule, okay? So let's get into it. So let's say we have a vector v, which is v is equal to, let's say x1, y1. So let's say if we have a dot product itself, so that is v dot v. So this means that x1, y1 dot x1, y1. To find the dot products, so what we need to do is we just times the x component together, and then we add the multiplication of the y component. That's all it is, okay? So that is equal to, so x1 times x1, we just write x1 times x1, and then we add the multiplication of the y component. So that is plus y1 times y1. So that will give me x1 square plus y1 square. So if you think about it, so let's say vector v is here. So vector v, so this is x1, this is y1. So this means that the horizontal distance is x1 and the vertical component is y1. So the magnitude of this is x1 squared from Pythagoras theorem, because this is the hypotenuse, plus y1 squared. So square root, right? So therefore, x1 squared plus y1 squared is the magnitude of v squared. So that is equal to magnitude of v squared. So there you go. So this means that we have v dot v is equal to the magnitude of v squared. So please keep that in mind for me, okay? So let's say we have another vector. So let me just move this up. So let's say we have another vector. So that is vector u is equal to x2, y2. So therefore, v dot u, which is, we know that v is equal to x1, y1. So v dot u, which is x1, y1 dot x2, y2. So v dot u, which is times the x component together. So that is x1 times x2, which is x1, x2. And then we add these two components times together. So that is y1 times y2. So that is y1, y2. So there you go. So therefore, we know that v dot u is equal to x1, x2 plus y1, y2. So let's draw these two vectors on a diagram. So we have vector v, just somewhere here, okay? This is vector v, this is y component, this is x component. And vector u is here. And then the angle between is angle theta. So this displacement vector here, let's name this displacement vector p. So we know that v plus p is equal to vector u, correct? So therefore, let me just write this down. So v plus p, which is equal to vector u. So if I move the vector v on this side, so this means that p will give me this. So vector p will give me vector u minus vector v. So now let's just focus on the magnitude, the size, okay, the side length of the vector rather than the vector itself. So let me just redraw the diagram out, just a triangle, because we just focus on the length of the vectors. So we have a triangle here. So this is P, which is U vector U minus vector V. Magnitude, okay, which is focused on the length, okay, the magnitude, if you like. So this is V, and this is magnitude of U. And the angle between two vectors is theta. Now from cosine rule, so we know that is C squared is equal to A squared plus B squared minus 2AB cos of the angle in between, that is angle C, okay? Now in this case here, the theta is angle C because it's always opposite C, okay? Remember that. So now I just replace the magnitude vector into the formulas. So therefore C squared, so this is C, okay? So let's just move this up. So we know that U vector U minus vector V, the magnitude square, that is C square equal A. So A and B is either magnitude of U or V, doesn't really matter. So that means U vector U square plus vector V square minus 2 lots of vector U and then vector V, magnitude of course, and cos angle in between. So that is the angle theta. So just write this down. Now from earlier, we know that V dot V is equal to magnitude of V square. So therefore, if we have U minus V magnitude square, so this is exactly the same as U minus V dot U minus V is exactly the same, okay? So now I just write this down. So this will give me U minus V and dot U minus V, which is equal to magnitude of U square plus magnitude of V square minus 2 magnitude of U and times magnitude of V and cos of angle theta. To find out the dot products for this, so what we need to do is we just do exactly the same as expanding binomial products. So this is just like U dot U, okay? So vector U dot, and then we go U dot V, but minus U dot V. And then we go minus V dot U is exactly the same as minus U dot V. And then we go minus minus, give me a positive, so plus V dot V, which is equal to magnitude of U square plus magnitude of V square minus 2 magnitude of U times magnitude of V and cos angle in between theta. So let me just move this up. Now we just simplify this. So we know that U dot U is magnitude of U square. So let me just write this down. So magnitude of U square. And then we have V, U dot V and U dot V. So minus U dot V minus U dot V is 2 lots of U dot V. So that is equal to minus 2 lots of U dot V. And then we have V dot V. So V dot V is V square, magnitude of V square. So we add the magnitude of V square. So now I just write out the right hand side. So this is U magnitude of U square plus magnitude of V square. And we minus 2 U and V and then cos of the angle in between. So there you go. So now if we minus the vector U magnitude of U square, both sides, you can see, and we can cancel this out. Similarly, we can just minus both magnitude of V square out. There you go. So now what's left is negative 2U dot V is equal to negative 2 magnitude of U and magnitude of V, and then cos of angle in between. So therefore, we can divide by both by -2, and this cancel out. So therefore, so vector U dot vector V is equal to magnitude of U, magnitude of V, and cos angle in between. So there you go. And we also know that U dot V is equal to, in component form, is x1, y1 plus x2, y2. So therefore, I can just write all in one line. So that is U dot V is equal to magnitude of U times magnitude of V, cos angle in between, and also equal to x1, y1 plus x2, y2. So please keep this in mind, okay? So there you go. So we just did this, and this rule, okay? So next video, I will go to this syllabus dot point with you, okay? Thank you so much for watching. Bye.